In this lesson, we're going to learn how to convert between the different forms of quadratics. So remember that there are three different forms of quadratics that we've talked about. There's standard form, factored form, and vertex form. And as we learned in the previous lesson, each form tells us something a little bit different about the quadratic in terms of the characteristics. So first off, we're looking at this first example here. We're given f of x equals x squared minus 2x minus 63. This quadratic is written in standard form, so the characteristics we know automatically. Number one, we know the concavity. And remember, to determine the concavity, we look at the a term, which is a number in front of x squared. And since that is positive, we say it's concave up. So we would say up because a is greater than 0. And then the other thing that we know from standard form is the y-intercept. And for that, we look at c, the constant term. That's negative 63. So my y-intercept is 0, negative 63. So we can't get any other characteristics just by looking at the form. However, we can convert it to the other forms to determine some other characteristics. All right, so starting with converting from standard form to factored form. In order to convert it, all we need to do is factor it. So how we convert it to factored form is we factor the quadratic. So factored form looks like this. This is what we want our quadratic to be. So using the box method, I have my quadratic that I'm going to write across the diagonal. So we have x squared minus 2x minus 63. And then we're going to find the numbers that multiply to make negative 63, that add to make negative 2. Since we're multiplying to make a negative number, I know that one has to be positive, the other has to be negative, and I'm going to list out my factors of 63. So that's 1 and 63, 3 and 21, and 7 and 9. So the pair that's going to get us negative 2 is going to be 7 and 9, and in order for it to be negative 2, I need the 9 to be negative. So then we can double check that 7 times negative 9 is negative 63, and 7 plus negative 9 is negative 2. So that goes inside the box. So that's going to be positive 7x, and that's going to be negative 9x. And then to get the outside, we find the GCF. So looking at x squared and 7x, my GCF is x. Negative 9x and negative 63, my GCF is negative 9. X squared and negative 9x, my GCF is 9. And 7x and negative 63, my GCF is 7. So factored form is going to be f of x equals x plus 7 and x minus 9. So we've now converted the standard form to factored form. Now, based off of that, we can get some additional characteristics. We now know the zeros. And remember, to get the zeros, we use zero product property. We do x plus 7 equal to 0. And x minus 9 is equal to 0. So in this case, x equals negative 7 and x equals positive 9. So my zeros are going to be negative 7, 0 and 9, 0. Okay, now we're going to talk about how to go from standard form to vertex form. So here's our quadratic in standard form, and we want it to look like this. So in order to do this, what we're going to do is we are going to find the vertex. So find vertex using our formula, x equals negative b over 2a, and we'll then plug in. And then we're going to use the same a value. Okay, so if we look at factored form, we need to fill out a, h, and k. So we're going to find h and k using our formula. And then whatever a is in standard form, we're going to use the same a. So since a equals 1 here, that means a is going to be 1 here. Okay, So let's go ahead and write that down. A equals 1. So we know that we're going to plug that in. And then now we need to find the vertex. Okay, so to find the vertex, we're going to use our formula. X equals negative b over 2a. Well, a is 1, b is negative 2, and c is negative 63. So it's going to be negative negative 2 over 2 times a. So that's 2 over 2, which is 1. So that means the x-coordinate of my vertex is 1. To get the y-coordinate, we're going to plug in 1 to our function up here. Okay, so plugging in 1 for x, we get 1 squared minus 2 times 1 minus 63. And when we do that, 1 squared is 1, negative 2 times 1 is minus 2, minus 63. We get negative 64. So the y value of my vertex is negative 64. So now we're going to use these two pieces of information, the a value and the vertex, to write my function in vertex form. So it's going to be f of x equals a is 1, or you can just write nothing. And then it's going to be x minus 1, remember it's the opposite sign, squared minus 64. So there it is in vertex form, and now we can get two other characteristics. We now know the axis of symmetry, which is what we got using this formula up here. So that's going to be x equals 1. Remember, the axis of symmetry is just the x-coordinate of the vertex, and then we found our vertex. That's going to be 1, negative 64. So now that we've converted it to the two other forms, factored form here and vertex form here, we're able to get all the other characteristics of our parabola. All right, so now let's talk about how to go from factored form to the two other forms. So this quadratic right here is written in factored form. I can tell it's in factored form because we have two parentheses, and it looks like a factored quadratic. So factored form tells us two things. Remember, all the forms tells us the concavity. And for concavity, we look at the a value, and since that a is positive, the concavity is up because a is greater than 0. And the other thing we can get from factored form are the zeros, or the x-intercepts. And to get that, we use zero product property, so x minus 9 equals 0, and x minus 5 equals 0. So that means x is going to be 9, and x is going to be 5. So written as a ordered pair, it's going to be 9, 0, and 5, 0. So in order to get the other characteristics, we have to convert it to the other forms. Okay, so going from factored form to standard form, all we need to do is we need to multiply it. Okay, so what I mean by that is we need to take this quadratic and just multiply it out. So in order to do that, what I'm going to do is I'm first going to multiply these binomials. So x times x is x squared. X times negative 5 is negative 5x. Negative 9 times x is negative 9x. And then negative 9 times negative 5 is positive 45. And then we have the 5 out in front. And then simplifying the inside, we have x squared. We can combine like terms here, minus 14x plus 45 with a 5 out in front. And now we can distribute that 5. So this is going to be 5x squared. 5 times negative 14 is negative 70x. And then 5 times negative 45 is 225. So there it is in standard form. And remember, standard form, it tells us the y-intercept. And to get the y-intercept, we look at C, and we write that as an ordered pair. So it's going to be 0 to 25. All right, now to go from factored form to vertex form. Okay, there's a few different ways to do this. what I'm going to show you is a way to get the axis of symmetry without having to use standard form. So to do that, going from factored form, what we're going to do is we're going to average the x values to find the axis of symmetry, and then plug in to find the y value. And just like the one that we did before, we're going to use the same a value. Okay, so this is just another way to find your axis of symmetry. We know how to find the axis of symmetry in standard form. We use negative b over 2a. This is just another way that you can do it. So we know our zeros are 9, 0, and 5, 0. So to find the axis of symmetry, we're going to add 9 plus 5 and divide by 2. So that's finding the average, also known as kind of finding the middle. So that's going to be 14 divided by 2, which is 7. So that means my vertex has an x coordinate of 7. And then just like before, to find the y value, we're going to plug in 7 for x in my function. So we're going to plug in 7. So f of 7 equals 5, 7 minus 9, and 7 minus 5. So that's going to be 5 times negative 2 times positive 2, and that's going to be negative 20. So my vertex is 7, negative 20. So the other thing I need is I need a. A is a number out in front. A is equal to 5. Now all we have to do is plug everything in to put it in vertex form. So vertex form is going to be f of x equals a, which is 5. And then we're going to plug in our vertex here. So it's the opposite value for x. So x minus 7 squared minus 20. So now that we've converted it to vertex form, we know our axis of symmetry, which is going to be x equals 7. And then we know our vertex, which is 7, negative 20. All right, the last conversion we're going to do is we're going to be going from vertex form to the other two forms. So vertex form, the characteristics we know right off the bat without having to do any calculations is we know the concavity. And for that, we look at the a value. So since a is negative, we're concave down because a is less than 0. We know our axis of symmetry, which is just the x value of the vertex, or it's whatever h is. So remember, it's the opposite sign. So this is going to be x equals negative 3. And then we also know our vertex. Our vertex is, we use h and k. So here's h and here's k, and it's the opposite sign for h. So it's going to be negative 3, comma 2. Remember, it's the same sign for k. So in order to find the other two forms, we do have to convert it. Okay, so first, to convert it to standard form, what we're going to do is we're going to multiply it out. Okay, this is a little bit complicated because it's a few steps, but just follow the steps here. Okay, first thing we're going to do is we're going to expand this. So x plus 3 squared, we can write that as x plus 3 times x plus 3. Okay, and then don't forget about that plus 2 at the end. So then what we're going to do is we're going to now multiply. So what I'm going to do, like I did before, is I'm going to multiply this binomial. So this becomes x squared plus 3x plus 3x plus 9 with a negative 2 out in front, and then combining like terms on the inside, we can combine these 3 x's. So that's x squared plus 6x plus 9, and then the plus 2 at the end. And then I'm going to distribute the negative 2 inside the parentheses. So that's negative 2x squared minus 12x minus 18. And then again, don't forget about the plus 2 at the end. And then last thing we're going to do is going to combine like terms. So our final answer is going to be negative 2x squared minus 12x minus 16. So again, to go over that process one more time, first thing we did is we expanded this exponent to x plus 3 and x plus 3. Everything else stayed the same. And then I multiplied these binomials and combined like terms. That got me x squared plus 6x plus 9. And then I distributed the number out in front and then combined like terms in the end. So really all we're doing is order of operations, right? We start with our parentheses and exponents, and then we do our multiplication, and then we do addition last. All right, so now we've converted it to standard form. And remember, standard form, the additional characteristic we get is our y-intercept, and we look at C for that. So our y-intercept is going to be 0, negative 16. All right, so now to convert it to factored form, there is no direct way that you can go straight from vertex form to factored form. What you have to do is you have to go from vertex form to standard form, and then you're going to take the standard form, and then you're just going to factor it. So in order to convert from vertex to factored form, you have to first convert to standard form. And then factor. Okay, so since we've already converted it to standard form in the previous step, we know that that's f of x equals negative 2x squared minus 12x minus 16. Now we're just going to factor it. So the first step of factoring is checking for a GCF. And in this case, my GCF is going to be negative 2. Remember, it's negative because our leading term is negative. So factoring out negative 2, we have x squared plus 6x plus 8. And now we're going to use the box to factor the quadratic. So I have x squared plus 6x plus 8. Sorry, that's a little messy here. Okay, and we're multiplying to make 8, and we're adding to make 6. So listing out my factors of 8, 1 and 8, 2 and 4. So it's obviously going to be 2 and 4. So we have 2x and 4x, and then let's get the outside here. So GCF is x. The other way you can get the outside is just work backwards. So x times x gives me x squared. X times 2 will give me 2x. X times 4 gives me 4x. So now I've factored it to write it in standard form. Don't forget about your GCF out in front. So that's negative 2. And then we have x plus 2 and x plus 4. So here it is in standard form. And now additional characteristics that we know are our zeros. And to get our zeros, we use zero product property. So we set the factors equal to 0. So x plus 2 equals 0, and x plus 4 equals 0. So we have x equals negative 2 and x equals negative 4. So my zeros written as coordinates are going to be negative 2, 0, and negative 4, 0.